In this video, we will look at detached DOM elements as a possible cause for memory leaks and how we can detect them and even possibly fix them. Hi, I'm Rohan, and this video is part of a series of videos where we are exploring how JS manages its memory in depth. More specifically, looking at various use cases that are the common causes for memory leaks and how we can understand and avoid these types of coding patterns. So let's get to it. Let's look at detached DOM elements and how they contribute towards memory leak. Whenever we have direct references to DOM elements, then even if we remove those elements from the document body, they will persist in the heap memory as detached elements. Now, depending on our code, these references may be surviving because they are global variables or because of surviving closure objects. This creates a possibility of a memory leak. Let's look at an example. Here we have an HTML file with a script tag. Inside this, we will create a function called populate DOM. Inside populate DOM, we will create a function called create element, which will accept tag ID and content. This function creates a new element using tag, assigns it the ID, assigns element.textContent with content or an empty string, and then returns the created element. Outside it, we will create a div element by calling create element using div tag and then assign the result to the variable container. After that, we will create an empty array elements. Then we will run a big loop inside of which we will create a button using create element with button as tag, I as ID and content as button with I, and push this button element into the elements array. After that, we will replace all the children of container with elements and then add container as a child to document body. In the return statement of populate DOM, we will return a function remove container, which will remove the container element from the DOM and log container and elements. Outside this function, we will call populate DOM and assign the returned function to a variable. We will also add a click event listener, which will call a callback function that will call remove container and then remove the event listener. Let's open this in a browser tab, open DevTools and then go to the memory section. Here we will record a snapshot of the page. Then click on the page itself and then record another snapshot. Now, my expectation is that after I clicked on the page, the snapshot size that is recorded after the click event is smaller than the one that is recorded before, which didn't happen even though we removed the container element and removed the event listener. Let's click on the first snapshot. We can see at the top that we have lots of HTML button elements. And if we expand closure, then we can see that we have closures for remove container and populate DOM. Remove container further contains the variables container and elements, which is a big array. Let's select the second snapshot and we can see at the top that we have lots of detached HTML button elements, which is taking up so much space, and this is contrary to our expectation. Also, if we expand closure, then we can still see closures for remove container and populate DOM. These clearly indicate that we have a memory leak. Let's fix these issues. So we go back to our code. Here, the first thing we will do is remove the elements array from populate DOM. So we remove elements declaration and assignment. After that, we remove elements.push in the loop and directly add button element as a child to container and then remove container.replace children. The next thing we need to do is remove the reference to the container element after it's removed from the DOM. So we will change the variable container from const to let. After that, inside replace container function, we will remove console.log and replace it with container set to null. Let's also wrap everything inside the script tag in an immediately invoke function expression. This way, all the closures will be cleared once the event listener is removed and nothing is declared in the global scope. Let's open this in the browser, open DevTools and then go to the memory section. We will record a snapshot of the page, then click on the page itself and then record another snapshot. Now, the first thing I notice is the sudden reduction in the size of second heap snapshot compared to the first, which is excellent. Let's click on the first snapshot and we will notice that we have lots of HTML button elements. And if we expand closure, then we can see that we have closures for click event and remove container. And notice that we have no closure for populate DOM. This is because we have put everything inside of an immediately invoked function expression. If we expand click event, then we can find that it contains remove container in its scope. And if we expand remove container, then it contains a reference to the container element, which is also expected. After this, click on the second snapshot and we can confirm that there are no more HTML button elements. And if we expand closure, then we can see that our function closures are removed from memory. And this is what we wanted. So to conclude, we should remove all the references to detached elements in our code as soon as possible, along with event listener, closure objects, and avoid using global variables if we can. So to quickly summarize, we looked at detached DOM elements as a source of memory leak using an example and how exactly we can fix it. In the upcoming video, we will look at caching as a potential source of memory leak. If you have liked this video, consider liking and subscribing. Thank you for your time. Have a nice day. Namaskar.